Before we do that, just going over the reminders. For periods 1, 3, and 5, you guys are taking your final May 23rd. My period 6 is taking it May 24th. You are allowed to use a 3x5 inch index card, but you have to turn it in once you're done with the test. The final exam reviews modeled after the actual test, but with different numbers. And blue puzzle pieces for a grade due by midnight on Monday, no exceptions. And the green puzzle piece is extra credit. So now that we talked about that, any questions from the review? Angel, number 7. All right, so the coordinate plane below shows the graphs of 3 functions of f of x, which, and I know it's hard to see on my screen, maybe yours too, but f of x is that red line. So what type of function is f of x? Okay, good. It is linear because it looks like y equals mx plus b. And when you look at it, it's a straight line. So it's definitely y equals mx plus b. And then h of x, what type of function is h of x? All right, it's that green line equation with something like that. Okay, no one can tell me. So then, what type of function is g of x? G of x is the blue one, looks like this.
Exponential.
Okay, now you guys have it backwards. All right, so g of x, the blue one is quadratic. Okay, and then quadratic, and then the green one is exponential. Okay, so quadratic has the x squared in it. Exponentials have it where it's something like a times b to the x power. So the exponent itself is the variable versus this, where it's a 2. Okay, so there's the 3 main ones we learned this year. And it says of f of x and h of x, so of the linear and the exponential, if any, which one would eventually exceed the quadratic as it goes to positive infinity? So positive infinity is what direction? Up, and then to the right, it kind of doesn't really specify on the x or y. I would think x because it has the x there, but not really sure. But yeah, as it's going up and to the right, do you think that the linear would exceed it? Yes or no? Do you think that the exponential would exceed it? So exponentials eventually exceed the other types. So because exponentials grow or decay at a really fast rate, if it's growing, it'll eventually exceed the others, no matter what. So as you can see, when you're looking at them just from this point of view, the exponential has the greater y values, right, for each x versus the other 2. So definitely exponential. Linear, I don't think will exceed it because as you can see, this one's kind of going like that, and linear is going like this. So like they cross, and then the blue one is still higher. So I would not pick the linear ones. I would just say h of x. Has anyone turned it in yet?
I do.
Do we know what the real answer is for that one?
I do the right.
Okay, let me take a peek at my answer key. I know is that given enough time, exponentials will always exceed quadratics and linear functions. All right, really, if it has you plugging anything in, then you should check. But if you're just being asked which one will eventually exceed the others, exponentials always do. So questions on this one? All right, so just a reminder, if this helps you at all, quadratics, have that U shape, and there's a U in quadratics. So that's how you can remember the shape of it. Exponentials. And I forget how someone drew it, but I think they did something like, I don't know, I saw a graphic, but something like that where it's like exponential, like where it goes up at a really fast rate or down at a really fast rate. And I think it was like with the X. All right, so something like that to help you, and then linear is just a straight line. Okay, questions on any other part of the review? Lauren? Number 4. Okay, calculate the average rate of change of f of x equals 4x squared minus 3 between x equals 5 and x equals 7. So average rate of change, anytime you hear that phrase, you should think of a certain formula. What's that formula? Okay, good. You can use that. That's also called our slope formula. But you could do that for any type of function. They just have to tell you where to look at. Oh, my bad. Yes. Sorry. So this would be a good formula to have on your note card. All right, but you can use that to calculate average rate of change for more than just linear functions. You just need essentially 2 coordinates. Now, we don't have 2 coordinates here, but we do have 2 x's. One of them is 5, the other one is 7. And we can figure out the y. Do you guys know how to figure out the y? What else does it give us in here? It gives us a function, it gives us an equation. So what you could do, it's written in function notation, it has x's in it. It says like when x equals 5, so plug in 5 for the x, like that. And then put that in your calculator. So yeah, I would put it in all at once. 4 times 5 squared minus 3. 97 for that one. That y value. And then you do the same thing, but now when x is equal to 7. And then you'll figure out that y value for when x is 7. So any questions on that? Okay, so then now doing the same thing, just now it's 4 times 7 squared minus 3. 193 is that y value. So then pair them up if they're correct ordered pair. And now you can do x1, y1, x2, y2, and plug it in. So the way that I labeled it, it becomes 193 minus 97 over 7 minus 5. And you need to work out the numerator and denominator before you can divide them. So I just need to do 193 minus 97. I do the other one in my head. All right, so 96 over 7 minus 5, which is 2. So now we have 96 divided by 2. Sorry, I made the calculator all wonky. Is 48, right? Okay. So yeah, that equals 48, which is one of the answer options. I don't know how to move this now that I put it all the way over there, but it is, if I remember correctly. So that's our average rate of change. Questions on that? So yeah, good thing to put on your note card. Highly encourage you to make one. Other parts of your final, Caitlin F. 11. Okay, this one's 11. So we're solving and it's a quadratic, so we've learned a bunch of different ways to solve them. What way do you guys want to use to solve this one? Okay, graphing. When you're graphing, I don't know if it'll let you just type it like this, we'll see. It probably does. Okay. But normally, like, you would want to set it equal to 0 and all that stuff. But Desmos is really user-friendly, so you can probably get away with not even doing that. That's why you guys should buy a graphing calculator. The only thing is when you don't set it equal to 0, you can't see that nice U shape. So if it was asking you for like your maximum or whatever, then you would want to really make it equal to 0. But it'll still show you where it crosses at the x-axis. It crosses at 6 and 7. So you just have to know where to look on your graph, look at the x-intercepts, that's where your solutions, zeros, whatever you want to call them would be. And yeah, that should be B on that one. It might be shuffled on yours, so just pay attention. Questions on this one? Questions on others? Number 8. Okay, so the length of a rectangle is 3 inches less than 2 times the width. The area of the rectangle is 256 square inches. Write an equation describing the relationship between W, the width of the rectangle in inches, and the area in square inches. So you would need to know the basic formula for area of a rectangle. What would that be? Okay, good. So then you can plug in the information that it does give you. So for example, does it tell us what the area equals? So then let's put that there. So that covers that part. Does it tell us about the length? So length of a rectangle is 3 inches less than 2 times the width. So do we know what the width equals? Anywhere else what the width equals? So then we have to write an expression for the length. So it says the length is, so length equals 3 inches less than. What does less than tell us to do? And is it going to be 3 minus 2 times the width or 2W minus 3? Okay, good. Because less than, that's kind of like a switch word is what I tell my students. And when you see that, you're going to switch the order. Because order does matter in subtraction. If it's less than the 2 times the width, you want to put it second. Okay, so then my length is 2W minus 3. We're going to plug that in here. And then we still have to times it by the width because that's area, length times width. Notice none of them have parentheses, so we probably have to distribute that W. What's 2W times W? Okay, good. W times -3. -3W. Which one best matches what I have? B. I've also seen problems where they also want you to set it equal to 0. So this one we don't have to because B matches it. But if we wanted you to set it equal to 0, how do you make the 256 0? And whatever you do on one side. Okay, great. And then so another way you might see it that would also be correct is something like this. Okay, so just like check your answers, see which one is still accurate, even if they didn't necessarily write it like this. Questions on this one? Questions on other parts? There's 18. All right, so we're matching graphs. So if f of x equals x squared. Oh, okay, so this is like function notation to the max. So if I have g of x is equal to negative f of x, and we know that f of x is x squared, we're gonna make that negative. So we're gonna do negative times x squared, which becomes what? Don't overthink it.
Negative x squared.
Negative x squared. So g of x is the equivalent to negative x squared, because f of x is x squared, and we're just making it negative. Does that make sense? Do you guys know what that graph would look like without even graphing it?
Downwards.
It would open downwards. When your a is negative for your quadratics, it opens downwards. So that might cancel out a few of them. And you can also verify in Desmos to make sure. This one, okay, so we know what g of x is now. We know that g of x is negative x squared. H of x wants us to take the negative x squared and then minus it by 3. When you plug in these parentheses, the parentheses don't really make a difference. So now how will this graph look? Does it open up or down?
Down.
Down. And this one, I don't know if you guys remember parent graph at all, but the parent graph, x squared, like the most basic quadratic, always has the vertex at the origin. So this one, g of x should be at the origin, just flipped. And then the other one, what does minusing 3 do to the graph? It goes in what direction? Up, down, left, or right? Not left. Down. 3. Okay, on Monday, we can go over vertex form. I do plan to give you vertex form on the test, but I don't tell you how to use it on the test, but we could talk about it Monday. So then to answer this, it looks like this one goes here.
Oh, do we turn it on?
You keep it, it's yours. I'll score you based on your blue puzzle piece, which matches that. Okay, so it'd be like that for this one.